Let us see how to construct a perpendicular bisector. What is a perpendicular bisector? It is a perpendicular bisector of a line segment is a line that cuts the line segment exactly in half and is perpendicular to the line segment. Now let us see how can we construct it. First of all, we draw the line segment XY for which we want to construct a perpendicular bisector. Then using a fixed radius, we'll draw arcs from point X and point Y above the line such that they intersect at a point A. So we'll just take the compass, open it to any length. Usually in order to draw a perpendicular bisector, we should open it to more than half the length of the segment. So we can just randomly take a length which is more than half. Then we keep the needle at X and draw an arc, and then we keep the needle at Y and draw one arc like this. Now these arcs intersect at point A. Next, we using the same radius from X and then from Y, we construct two arcs below XY. So there goes one arc and then another arc from X, and we call this point as B. Lastly, we'll join AB, and AB is the required perpendicular bisector. Now, once we do it, we see that all the points which lie on the perpendicular bisector of XY are at equal distance from X and Y. For example, this point. This is a point which lies on the perpendicular bisector, right? It is at equal distance from X and Y. That is, AX is equal to AY. Similarly, this point, it's at equal distance from X and Y. This point or this point, they are at equal distance from X and Y. Now just think about this. Is it really necessary to have the same radius for the arcs below and above XY? Let's see. So let's say we took 5 centimeter as the radius and drew two arcs from X and Y above the line. And for the arcs below the line, let's say we take a radius of 4 centimeter. Now, the distance from this point to Y is 4 centimeter. The distance from this point to X is 4 centimeter. So this point lies at equal distance from X and Y. So is this point. So that means these points lie on the perpendicular bisector. That is what we saw, right? All the points on the perpendicular bisector are at equal distance from X and Y. So that means it is not necessary. We can totally choose different radii for arcs above and below XY. It is not necessary to have the same radius, as long as both arcs in a pair are drawn with the same radius. That is, this pair, these two arcs should be drawn with the same radius from X and Y. And similarly, this pair should be drawn with same radius from X and Y. Once, if we do that, their intersection point will be equidistant from X and Y. The perpendicular bisector is actually a line which is a set of all points equidistant from X and Y. So if we use radius, let's say R1 for arcs above and radius R2 for arcs below, we get two intersection points, both equidistant from X and Y, even though their radii differ. Joining them will still give us the correct perpendicular bisector. So to conclude, we can say radii must be equal within each pair of arcs. But radii can differ between the above pair and the below pair. Next, think about this. Can we construct both the pairs of arcs on the same side of XY? Something like this. Well, yes, we can. If we draw both the pairs of arcs above or below the line and they intersect, we'll still get two valid points to draw the perpendicular bisector. We can join them and then further extend the line so that it intersects XY. And we'll still get the perpendicular bisector. Now, why we usually draw a pair of arcs above and below is because it's more symmetric and visually clear. Having intersections on opposite sides makes it obvious that this line will pass through the midpoint of XY and is perpendicular to XY. And this is why, as a practice, we draw arcs on the opposite sides of XY. Using this knowledge, let us construct a 90-degree angle at a given point. For example, we have this line and a certain point O on it, and we want to draw a 90-degree angle at this point. Now, what we can do is, using a compass, we can mark 2 points X and y at equal distance from O. That means O is the midpoint of xy. Now, we know that if we drew the perpendicular bisector of xy, it will pass through O and it will be perpendicular to this line that is at 90 degrees. Now, if we want to draw a perpendicular bisector, we basically need 2 points, right? But we already have one. We already have 1 point for the perpendicular bisector. So we just need one more point. So that means we need to draw only one pair of arcs from x and y to get the second point. So let's just keep the compass at x and draw one arc, then keep the compass at y and using the same radius draw second arc and then join these 2 points. Now this is the perpendicular bisector and we know that it is making 90 degree with this line xy. That's how we just drew 90 degree angle at a specific point. You know, in the Vedic times, when we did not have geometric tools, when we did not have compass or ruler, they used different kind of tools to draw, let's say, angles or perpendicular bisectors. You would be surprised that a rope can be used to draw a perpendicular bisector. Let us see how. Let xy with the line segment drawn on the ground for which we want to construct a perpendicular bisector. So what we'll do is, we'll fix 2 pegs vertically on the ground at x and y. Then we'll take a rope and tie it with the loops at both ends and we'll mark a midpoint. Ignoring the part of the rope that is including the loops, we'll just mark a midpoint of the remaining rope. Then we'll pull the rope from that midpoint above xy like this, such that the 2 parts of the rope on either side are fully stretched, and we'll mark this position of the midpoint as A. Then we'll similarly pull the midpoint of the rope below xy and mark this position of the midpoint as B. Lastly, we'll just join AB and AB then becomes the required perpendicular bisector. Because once again, if you see the logic behind this, AX is equal to AY. That means A is the point which is at equal distance from x and y. Similarly, B is the point which is at equal distance from x and y. And we can just join them and thus we'll have this perpendicular bisector because it is a set of points that are at equal distance from x and y.